Hi, welcome to Dr. Pat TV, and we're looking at the definite integral. We'll look at it in the numerical and graphical perspective, and then in another video, another section, we'll look at it in terms of the symbolic, working the formulas. All right, so just kind of get the idea across. Just got a weird example. So let's say you're driving 62 miles per hour for 2 hours. How far have you gone? Yeah, nice straightforward question. It's not a trick question. Um, Basically, hopefully, you all agree it's 124 miles. Well, how did we get that? Well, we take the 62 miles per hour and we multiply by that by 2, the number of hours that we drive. Okay, so now what we want to get at is graphically. So we can do that number wise, but graphically, when we got the speed graph, we got the rate graph, where's the total? I mean, how do I get the total distance that I've driven? Well, hopefully you realize that, 62 times 2 is actually an area. It's 62 is the height, and then the length here was 2. And so when we do length times height, we get the area. And so that's what we do here. We did 62 miles per hour times 2. That's the same thing as 62 times 2, which is this nice little area. And this area would be worth 124 miles. And so basically what we're looking at here, when we're doing graphical, you start with the rate graph, and what we have, the area between the rate graph and the axes is basically how far we've gone, the change in the total. When the rate graph is above the x-axis, we have a positive change, so that adds. If this rate graph was below the x-axis, that would mean we're driving towards something, then our total change would be negative. We're getting closer to something. Okay, and so that's basically what we're playing with. So how about an example here? I've got an instantaneous rate of change of stock A. What we have is the cents per hour. So that's where my rate of change is looking at. And so we're starting at time 0 with the stock value to be 8.50. So that's what we have down here. And so after the first hour, what has happened to the value of our stock? Well, basically, it's been consistent 8 cents increase per hour for that first hour. So this whole area right here would be 1 hour times 8 cents. The area here, 8 times 1, would give us an increase of 8 cents. Now, that's not saying our stock is a value of 8 cents. It's telling us that's how much total change, the total change in the value. We have to account for our starting value, and then we add the 8 cents. And so that's the game that we play. So then for the second hour, again, a repeat of 8 cents because this area is worth 8 cents, 1 hour of 8 cents per hour. And so you add that onto your running total, and our running total is 866. So if we started with 850 as our value of the stock, after 2 hours of increasing 8 cents per hour, we have an increase of a total of 16 cents with our new running total of 866. So look at what we're talking. We got a lot of different totals here. I've got running total, I got starting total, I've got change in total, and that's what this area represents here. The change in total, and then we've got as these running totals as we go on. And so now for the third hour, what we have here is a total area of 8.5 cents. Now how did I get that? Well, we've got a total area of 8 cents like before, plus this little triangle piece right here. And so what I have here, this triangle piece here, is an increase of a penny here with a base of 1. And the area of a triangle, hopefully you remember, is 1/2 base times height. I got a height of 1 and a base of 1. And so that's a half more. So the area of that little triangle is a half cent more. And so then I take that 8.5 cents and I add it to my running total here. And so that's where we're at. After 3 hours, we now have a value of 8.745. And then for that fourth hour, we add up that total area. The area of a rectangle here going from this point all the way down would be 9 cents. And then half a cent more for that triangle. So that would give us a total area of 9.5 cents. And then we add that to our running total. And then we keep on going for the fifth hour here. That's a nice straight rectangle worth 10 cents. So I add that 10 cents. Sixth hour, another 10 cents. The seventh hour, another 10 cents. And at the end of the eighth hour, we have another 10 cents that we add up. And so we started with 8.50. We added up all these changes in the total per hour. And then we ended up with a total at the end of the time period of 9.24. And so that's an example of how we play areas. We just calculate how things are changing. If we're doing it by hour, that's what I did here. You could do it for 2 hour period of time and just basically get these area of 16 cents for the 2 hour period of times. For a 4 hour period of change, there was a total change of 40 cents here. So you can kind of, if you know that you're going to calculate to the end and you didn't care about the value in between, you can kind of consolidate your areas. But that's basically the game we're playing. We're just calculating areas for rates of change. And so that's the beginning here. I've got some more examples coming in part 2.